If you are like me and have a spare PC fan lying around, then it is always a good idea to glue a neodymium magnet to each one of its blades and use a more powerful magnet to repel them, so that the fan spins forever and thus produces an unlimited amount of free energy. Sounds too good to be true, right? Well, in this video, let's play around with this infamous magnet PC fan and the so-called Bedini motor to find out how much free energy we can actually produce. Let's get started. First off, the setup for this magnet PC fan is fake. The light bulb is actually powered by one channel of my lab bench power supply, while the other channel provides a voltage of 2.7 volts for the fan so that it can slowly spin without raising too much suspicion, since it is impossible to accelerate the fan solely through the magnetic repulsion, because the magnetic attraction occurs a fraction of a second later and basically counteracts the rotation. But not only that, if we solder a red LED to 3 different PC fans and spin them, we can see that 2 LEDs stay completely dark and only one lights up decently for a very short amount of time. The reason is the driver circuit of the fans, which are all slightly different, but were all never intended to be used as a generator circuit. That is why the first fan basically outputs nothing. The second one outputs one half wave of a sine wave with a peak voltage of 1.5 volts, and the third one outputs 2 rectified halves of a sine wave with a peak voltage of 2 volts. And even if we use the fan with the highest output power, the LED's light intensity would only equal a power of around 0.01 watts. Definitely not enough to power a 21 watt light bulb.